Hey guys, what's going on? It's Dave with Evil Eye Gaming. Today we'll continue on with our third-person cover shooter, and we're going to deal with our cover AI. But first we're going to have to take care of a couple other things. Now, one thing I'm going to mention is I did already try to record this video, and I had some issues with recording, and I had to basically go back and re-record this. So I tried to revert everything as best as I could. If I run into something that isn't reverted, I'll go ahead and do it as we go. So the first thing I want to do is we're going to go into our characters folder, into our enemy character, and we're going to go ahead and open up our base enemy character blueprint. And the first thing I'd like to address is right now in our fire shotgun, we are using a function that we called calculate shotgun projectile. I'm going to open that up real fast. And the one thing I thought to myself is why are we using this just for the shotgun? We can use it for other projectiles as well. So in order to do that, I'm going to double click on the function here to rename it. And I'm just going to call this one, I'm going to rename it to calculate projectile info. And then I'm going to go ahead and add a new input to it. And I'm going to call this the spread, and I'm going to make it a float. And so right now we have the shotgun spread value plugged directly into our random unit in vector cone. So I'm going to go ahead and break that, and I'm going to connect our new input to the cone half angle. So that way we can plug the shotgun spread into the function itself and then use this function for other things as well. And one thing I'm going to note too while I'm at it with the shotgun spread, in the video where I made this, I ended up saying that the shotgun spread I calculated by using the ACOS of 1/10. Well, I went back and recalculated and I made an error. I gave you guys the wrong value. I think I named it as 1.0017. The correct method of calculating the spread is the A tangent of 1/10 in radians. And it comes out to almost 0.1. So I'm just going to round to make our lives easier. So I just want to set the shotgun spread here to 0.1. So we'll go ahead and compile and save. And you know what? I'll delete this shotgun spread value in here. And we'll go back to our event graph. And now where our calculate projectile info function is, we can go ahead and grab our shotgun spread and plug it into our calculate projectile info. So now we can use this when we go to calculate the spread on our rifle fire. And another thing we're going to have to end up doing is we are going to have to take care of him entering and exiting cover. So I'm going to grab all of our fire events here and I'm going to drag them down out of the way for a little bit. And we're going to have to implement the cover interface that we implemented with our player as well. So we're going to go to our class settings, and under interfaces we're going to click add and add our cover interface. And we'll go ahead and compile and save it so we have access to it. And I'm going to go ahead and right click, and we're going to search for our cover interface, which if I remember correctly, there we go, it's the event is cover available. So when the event is cover available is passed through, it passes in this variable if cover is available to us. So I'm going to go ahead and promote that to a variable. And we'll go ahead and call this cover available. And then there's also the cover rotation, so I'll go ahead and promote that to a variable. And we'll call this cover rotation. We'll drag everything out so we can actually read it. So that way our AI character will be able to know when he's entered cover and when he can actually take cover. Next, I'm going to go ahead and create a function. And I'm going to call this one set is taking cover. And I'm going to have one input. And we'll call this is taking cover. And we'll make it a Boolean. And we're going to use this function to set our enemy character to actually take cover. So the first thing when we call this function, we're going to want to check to see if cover is available. So I'll grab our cover available, we'll throw in a branch, and we'll connect the cover available into that branch. And if it's true, we want to go ahead and set that we're taking cover. So I'm going to right click on is taking cover, and we're going to promote to a variable. And we'll call this is taking cover. And we'll connect that to the true of our branch. So we now have a value to hold whether or not we are actually taking cover. And then we'll throw in another branch, and we'll base it off of this is taking cover. And we're going to want to set the actor rotation like we did with our player character. So I'm going to drag off of our branch true, and we will search for set actor rotation. And then we'll just go ahead and plug our cover rotation into that set actor rotation. And then from the false of our original branch, I'm going to duplicate this set is taking cover. I'm going to plug false into this set and make sure that is taking cover is set to false. So when we call the is taking cover function, we're going to check to see is cover available. If cover is not available, we're going to automatically just set is taking cover to false. If cover is available, we're going to set our is taking cover to whatever value we pass in. And if that value is true, we're going to set our actor rotation to the cover rotation that we took from our event where we overlap cover. So I'm going to go ahead and compile and save. And we can close out of these functions. And lastly, I want to go ahead and create a new variable. It's going to be a Boolean as well. And we're going to call this is aiming. And this will dictate whether or not our enemy character is aiming out of cover. And so we're going to go down to our fire weapon events, and we have our fire rifle. And for right now, we're going to do similar to what we did with firing the shotgun. So I'm going to create a new custom event, and I'm going to call this rifle burst. So from our fire rifle event here, the first thing I want to do is I want to check to see if we're actually firing or not. And I can't remember if I actually had this variable in place before this, but if not, go ahead and create a new variable that's a Boolean. We'll call it is firing. And we want to check this value and see if we're firing or not. So we'll drag out is firing. We'll perform a not operator on it. And then we'll put that into a branch. Now, if we're not firing, so in the event that that's true, we want to go ahead and set is aiming. And we want to set that to true. And we want to set is firing to true as well. And now when our enemy character pops out of cover, there's going to be a delay from the time it takes from him when we give him the command to start firing his rifle to him actually play the animation to stand up. So from the end of our set is firing here, I'm going to actually plug in a delay. And the standing up animation, I believe, naturally is 1.5 seconds. So I'm going to go ahead and set the delay to a duration of 1.5. Oh, and we're going to want to go ahead and set is firing to true as well. And then we're going to go ahead and create a new variable. I'm going to call this rifle burst count. And I'm going to make this an integer. And then we're going to go ahead and set this from our delay. And for the value of this, I'm going to drag this out. And I'm going to search for a random int in range. And I'm going to set the min to be 5 and the max to be 10. And then we're going to go ahead and call our rifle burst. Then once we call our rifle burst, we're going to go ahead and, like before, set a timer by event. And we're going to go ahead and plug the event into our rifle burst event. And we're going to set the time to the firing animation of the rifle, which is 0.233. And we're going to set the looping to true. And we'll go ahead and grab the timer handle, and we will set this to the timer handle of the timer we just created. And so we're going to head down to our rifle burst here, and we're first going to throw in a branch. And what we want to check on this branch is if our fire count is less than the rifle burst count. So we'll take that fire count, we'll get it. We'll get a less than, and then we'll go ahead and plug our rifle burst count. Into our less than and plug that into our branch. From here, we're going to grab the weapon mesh, and then we're going to go ahead, drag off of it, and search for play animation. We'll plug our true into the play animation. And then for the anim asset to play, we're going to be firing our assault rifle. So we're going to search for, I believe it's fire rifle. And we'll select the fire rifle W animation sequence. And we're going to go ahead and create another variable. And I'm going to call this the rifle spread. So just like the shotgun spread, we're going to have a spread for our rifle. And I'm going to make this a float. And I'm going to compile so that we can set the default for a rifle spread. And using the formula from earlier, the tangent or the A tangent of the amount of spread over the distance, I figured that I wanted to have about a 1 meter spread after about 20 meters away from our point of firing. So if we do the math, I'm going to round a little bit here, but it's going to be 0.055. And I'm going to set that to the default of our rifle spread. So we'll go ahead and we'll then call our calculate projectile info. And we'll plug our play animation into this calculate projectile info. And we'll connect our rifle spread into the spread of our calculate projectile info. And then from our calculate projectile info, we're going to drag out. And we're going to search for spawn actor from class. And the class of the projectile that we want to spawn is going to be our assault rifle projectile blueprint. We'll connect our projectile spawn info into the spawn transform. Set the collision handling override to always spawn ignore collisions. We'll go ahead and search for a reference to the self, and we'll plug this into our instigator. Then coming from here, we're already returning a assault rifle projectile blueprint reference. And as I had mentioned before with the shotgun projectile, the blueprints get really weird with this, and you may or may not have to cast this. So I'm going to drag out from here, and we're going to set damage info. And if you can't get access to the set damage info here, you're going to have to end up casting to the base projectile blueprint. And then from that cast, setting the damage info. And from here, we're going to go ahead and we're going to get our damage min and plug that in, and our damage max, and connect those into the set damage info. And then finally, we want to increment the fire count. So we're going to take our fire count integer, we're going to get a reference to it, and we're also going to set it. And from our fire count get reference, we want to search for an add an integer plus an integer, and add +1 to it, and plug that into our fire count. So this is pretty much the same thing that's going on with our shotgun, except we're not automatically taking a break. But essentially what we're going to do is we're going to start out by checking to see if we're not firing. If we're not firing, we're going to go ahead and set is aiming to true. We're going to set is firing to true. And then we're going to perform a delay, because if our character is taking cover, they're going to need time to get out of cover. And then we're going to set a rifle burst count, and we're going to set a random integer within 5 and 10. So that way it doesn't look robotic when the enemies go to fire. So they'll end up firing anywhere between 5 and 10 bullets every time they end up firing. And then we'll go ahead and call our rifle burst. We'll set a timer to that rifle burst event. And then we'll set our timer handle so that when we end up calling stop fire, it will release this timer handle. And then in our rifle burst, we're going to check to see first if our fire count is less than our rifle burst count. If it is, we'll go ahead and play the animation to fire the weapon. We'll calculate our projectile info using our rifle spread number. We'll spawn our projectile, and we'll set the damage for that projectile, and we will increment our fire count by 1. So I'm going to go ahead and select all of this. I'll put a comment box around it, and we called the other one fire shotgun, so this one we'll just call fire rifle. And the stop fire event is going to work with this because it's going to end up clearing that timer handle. But we also now set this is firing variable to true and is aiming to true. So we're going to have to go and unset those. So from the end of our stop fire weapon, after we clear the timer handle, we're going to want to set is firing to false. And we're also going to want to set is aiming to false as well. And then lastly, we also want to set our fire count to 0 as well. So I'm going to go ahead and we're going to compile and save, and we can go ahead and close out of our base enemy character blueprint. Next, we're going to go ahead and open up the anim BP for our enemy, and we're going to go into our state machine. And we're going to have to add a few new animations. So the first animation we're going to end up adding, we're going to search in our asset browser, and we're going to search for the idle to cover. And we're going to have to pick either a left or a right, because I don't want to make this animation tree too complex for our enemy characters. I'm going to go with the idle to cover right for the cover low, and we'll drag that animation out. And we'll call this idle to cover. Then we're going to have to get the cover right animation. So we'll search for the cover low, cover R animation. And we'll just call this cover. And then we're going to have to search for the cover R to idle. So we'll select the cover low, cover right to idle animation. And we'll call this one cover to idle. And we'll just arrange these out here. And what we're going to want to do is we're going to want to make a transition from our idle to our idle to cover, and as well from our movement to our idle to cover. Then we're going to go from our idle to cover to the cover node, from the cover to idle, and finally from our cover to idle back down to idle. And I'm just going to arrange these out so we can see all of the transitions. And we're going to have to go ahead and get some of the variables from our enemy character in order to make these transitions. So we'll go over to our event graph, And right now we have the aim at player after we cast to our base enemy player and grab the combat type. So I'm going to make some room. I'm going to drag this aim at player for our aim offset off to the side. And from our as base enemy character cast, I'm going to go ahead and drag out, and we're going to get is taking cover. And we're going to go ahead and promote this to a variable. And we'll call this is taking cover. And as well as our is taking cover, we're also going to have to get to see if we're aiming. So we're going to drag off of our cast as our base enemy character. And we're going to get is aiming. And once again, we're going to go ahead and promote this to a variable. And we're going to call it is aiming. And then we'll just go ahead and connect all of these in line. And we'll go ahead and compile. And it's going to throw up some errors because we haven't filled out those transition states yet. So we're going to go back to our state machine. And for our first transition from idle to cover, we're going to go ahead and open up that transition. And for this, we're going to get is taking cover. And we're also going to get is aiming. So we want to go into cover when is taking cover is true and is aiming is false. So we're going to add a not onto our is aiming. And then we'll drag out from our is taking cover when we'll search for an and operator. And we'll plug our is not aiming into the and as well. So this transition will occur when is taking cover is true and is aiming is false. And I'm going to copy this because this is going to be the same transition from our movement to our idle to cover. And I'm going to go ahead and paste that in place. And we'll go ahead and go back out to our state machine. Then from our transition from our idle to cover, we're going to open up that transition. I'm going to right click. We're going to search for a ratio. And we'll select the time remaining. We'll go ahead and search for less than and set it to 0.4. And plug this into our result. From our cover to idle, we're going to go ahead and open this up. And we want to go ahead once again and grab our is taking cover and our is aiming variables. And for this, we want it when is taking cover is not true or if aiming is true. So from our not, I'm going to drag out and get an or. We'll plug our is aiming into the or and the result into our result. So if is taking cover is false or is aiming is true, we're going to go ahead and exit our cover state. And then finally for the return transition here, we're going to go ahead and search for ratio once again and get the time remaining. We'll search for a less than and set the value to 0.4 and plug that into our result. And we'll go ahead and compile and save, and we no longer have any compiler errors. And we're going to go ahead and close out of our animation blueprint. I'm going to go ahead and go into our AI folder, and we're going to go into our behavior tree. So far we have our assault tree set up, and we want to set up our cover tree, but we're going to have to make some minor changes. And before we get started in this, I want to go ahead and explain explicitly how the behavior tree works, because this is extremely important to how the cover setup is going to work, and it's going to dictate how I'm going to change the assault tree. So for the behavior tree, we have three different types of composites, which are these nodes: the sequence, the selector, and the simple parallel. And one thing that's very important to understand is that what the tree is attempting to achieve is what is called a success. And one thing you've noticed when we've been making most of our tasks, when I get to the end of the task, I've been putting in a finish execute node and set the success to true. And it's important to know how the sequence, the selector, and the simple parallel end up defining what success is. So with a sequence node, for example, our patrol node right here, we have these series of tasks that go from left to right. And generally speaking, with these tasks, you'll see next to them that there's a number that ranges from 0 to the number of tasks that exist minus 1. And what will happen is, in general, it moves from left to right, where it attempts to set the waypoints, it sets the move to, it waits, it goes ahead and moves to another point, and then it waits again. And what will happen is, we'll do the set waypoint function, and it'll return a success, and then it'll move to the next task until that task returns a success, and so on until it completes the entire sequence. And a sequence is considered successful when all of the sub-branches end up returning successful. So if something were to happen to make one of these tasks in here unsuccessful, say for example we successfully set the waypoints and then attempts to go to the move to, but the move to returns a failure. What's going to end up happening at this point is this node is going to return a failure and it's going to flow back upwards. So this entire sequence node will fail if any of the tasks fails. With a selector, on the other hand, you have these two branches on our assault tree. A selector succeeds when any of the branches succeed. And you'll notice that there's numbers on the children of the selector as well. So for the simple parallel, it has a 0, and for the sequence, it has a 1. And that's the order it will attempt to run the branches. So coming down from this selector, it has a decorator on it. So if this decorator ends up saying, no, I can't run, this decorator case isn't true, it'll attempt to run the next branch from the selector. And this differs from a sequence because if the sequence couldn't run this task, it would stop right there. But the selector will try each one of the branches until it finds a branch that can succeed. So in this instance, if the check distance to player here ended up not being able to run, and then it went to the second sequence and it ends up performing all three of these tasks, this sequence here would return a success, which would return a success for the selector, and the selector at this point would return a success, passing it upwards. Likewise, if the simple parallel over here ends up returning a success, it will never end up running the sequence over to the right, regardless of whether a decorator prevents it from running or not. And then finally, the simple parallel here. This one is going to be different, and I'm actually going to get rid of the simple parallel for this purpose. Reason being is this simple parallel will run as long as the task that is connected to the purple node here is still functioning. So one thing you'll notice is if we open up the assault player BTT, is I never ended up adding a finish execute to the end of our chain here. And the reason being for that is because as soon as this assault player task returns a success, it closes this whole tree out. So what would end up happening is if the enemy player is trying to move towards the player character and the assault player BTT returns a true, it would never end up firing any of the walking down here because this would complete so quickly, none of this would actually end up working. But I want to be able to use this to start firing a weapon for both of our cover and our assault tasks. So we're going to make some changes to the way this functions. And what I'm going to end up doing is I'm going to drag out from our assault selector up here, and I'm going to search for a sequence. And we're going to drag the decorator for checking the distance to player over here, and I'm going to delete the simple parallel. And then from the sequence, I'm going to drag out and connect to our assault player, and I'm going to drag out and connect to our selector. Now, in order for the sequence to successfully cycle, we're going to have to change up our assault player BTT. And while I was at it, one of the things I was thinking was, why do we have two different functions, one for starting firing and one for stopping firing? So we don't really need a separate stop fire BTT over here. So what we're going to do is I'm going to go back to the main window, and I'm going to find our assault player BTT, and we're going to rename this. And I'm going to call this start firing weapon underscore BTT. So you know what? I'm actually going to rename this again, and we're going to go to the beginning, and I'm going to call this start stop firing weapon. So this one BTT is going to handle both starting and stopping the firing of the weapon. So I'm going to go back to our behavior tree, and I'm going to double click and open up this function, or this blueprint task. And we're going to add a new variable, and it's going to be a Boolean, and we're going to call this Boolean start firing weapon. And we're going to make this public so we can set it from the behavior tree. And I'm going to drag our fire weapon off here to the side, and we're going to go ahead and put in a branch. So after we cast to our base character, we're going to go ahead and enter the branch, and we're going to connect this start firing weapon Boolean into that branch. So if we set start firing weapon to true, we want this branch to go ahead and start firing the weapon. So we're going to go ahead and connect our true into the fire weapon. And from our fire weapon, we're going to go ahead and drag out, and we're going to get a finish execute. And we're going to set this to success to true. And then from the false node, we can drag out, and we're actually going to have to get our cast to our base enemy character here. We'll drag out and search for the stop fire weapon event, and we can connect this up to the false pin on our branch. And then once again, we can duplicate this finish execute, and we can go ahead and plug that into the end there, making sure that the success is set to true. So this node will now become multi-function for us, and we can use it in more than one place. So when we call on the start stop firing weapon, we can either use it to start firing the weapon, or we can use it to stop firing the weapon. So I'm going to go ahead and compile and save this, and we're going to close it. And from our assault player node here, it's still named assault player. I'm going to rename this to start firing weapon, and we're going to set start firing weapon to true. And I'm going to rename these nodes up here because we can actually use these to describe what the tree is actually doing. Now, on the sequence to the left here, we're checking to see if the player is within 11 meters. So I'm going to rename this node, and we're going to call it player within 11 meters. And then for the check distance to player on the other sequence, we're checking if the player is further than 11 meters, and we'll call this player outside of 11 meters. And then down on our lower selector here, within our sequence when the player is within 11 meters, we're checking our firing arc. All right, so in this left arc here, we're checking if our firing arc, if the player is in front of our player character. So we're going to, instead of calling it check fire arc, we're going to go ahead and we're going to call it player in forward arc. And then for the other one where we just moved to the player, we're going to call this one player not in forward arc. So now if we take a look at this from a high level, we can easily understand what's going on without looking at the details of each one of these decorators or the tasks as well. So if we just take a look at this, okay, this sequence ends up firing when the player is within 11 meters. This sequence fires when the player is outside of 11 meters. And that makes it a little bit easier to detect when we're just glancing at things from a higher perspective without actually having to look into things. And then for the stop firing weapon over here, we don't really need this anymore because we now have our start stop firing weapon. So I'm going to delete this, and we're going to drag out, and we're going to search for our start stop firing weapon BTT. And for the node name, we're going to go ahead and call this stop firing weapon. And we want start firing weapon to be set to false because we want to stop firing the weapon. So we can go ahead and save at this point. And at this point we can go ahead and start working on our cover. So in our cover sequence over here, I'm just going to drag these out a little bit so we have some more room to work. And from our cover sequence here, we're going to keep this as a sequence. And we're going to need a new task in order to dictate whether or not we're in cover. And we're also going to need a new Blackboard variable. So we're going to go over to our Blackboard. I'm going to add a new key, and it's going to be a Boolean. And we're going to call this is taking cover. So we'll save and go back to our behavior tree. And we're going to create a new task based on the blueprint base. So once again, I'm going to go back to our main window. And for this new task, I'm going to go ahead and rename it. And we're going to call it set is taking cover underscore BTT. And while we're here as well, we can actually delete the stop firing weapon BTT. So I'm going to go ahead and delete that because we don't need it anymore. And we can go back into the set is taking cover BTT. And in our task, we're going to go ahead and right click. And we're going to just search for the event execute, and we'll select the event receive execute AI. We're going to grab off of our pawn, and we're going to cast to our base enemy. And we're going to go ahead and we're going to call the set is taking cover function. And we want this to be set from the Blackboard tree. So we're going to go ahead and create a new variable. It's going to be a Boolean, and we'll call it set is taking cover. We'll make it public, and we'll go ahead and connect this into is taking cover input on the set is taking cover function. We're also going to have to get the variable on our Blackboard for is taking cover that we just created. So we're going to create a new variable. We're going to call this is taking cover. For the type, we're going to set it to the Blackboard key selector, and we will make it public as well. And we'll go ahead and grab a reference to is taking cover. And we want to set the Blackboard value as Boolean. And we'll go ahead and plug this in after our set is taking cover. And then we want to set it to this value that we passed through from our behavior tree. So we'll grab off from our set is taking cover variable, and we'll plug that into our value. And finally, we're going to drag off of our setting a value as a bool, and we'll search for the finish execute. And we will check success to true. And that's all we're going to need to do in our set is taking cover BTT. So we'll go ahead and compile and save, and we can close out of this task. So from our cover sequence here, the first thing I'm going to do is I'm going to drag off, and we're going to search for that set is taking cover BTT. And in the details, we want to set is taking cover false, and we want to connect the is taking cover variable to our is taking cover Blackboard value. And then for the node name, we can set this or call it set not taking cover. Next, I want to drag off of our sequence here, and we want to search for the start stop firing weapon BTT. And we want to set it so that it stops firing the weapon. So we want to make sure that start firing weapon in the details is false. And for the node name, we're going to call it stop firing weapon. Next, I want to go ahead and find cover for our enemy. So we're going to have to create a new task to do this. So I'm going to click on new task, We'll base it off the blueprint base. And as always, I'll go back to our main window and I'll go ahead and rename this. And I'm going to call this FineCover underscore BTT. And we can go back into our FineCover BTT. And we're going to actually need to create a new Blackboard value. So in our behavior tree, I'm going to click on Blackboard. We're going to create a new key, and it's going to be a Boolean as well. And I'm going to call this isCoverAvailable. So we can save and go back into our behavior tree. And then in our FineCover BTT, we're going to right click and we're going to search for the event receive execute. So we'll select the event receive execute AI. And we're going to want to get that isCoverAvailable Blackboard value. So we'll create a new variable. We'll call it isCoverAvailable. We'll set the type to a Blackboard key. And we'll make it public. And we'll go ahead and get a reference to this. And we want to go ahead and set as a Boolean. And the very first thing we're going to do is set this to false. Next, I'm going to create another new variable. I'm going to call this distance to cover. And it's going to be of a type float. And we'll create a second variable. We'll call it max distance to cover. And I'm going to compile this so I can set the max distance to cover default. And we're going to set this to a value that is going to be the max range our character is going to look for cover. We're going to end up creating a bubble around our enemy character from which we're going to search for cover. So I'm going to say let's make it like a 30-meter bubble. So that's going to end up being a value of 3,000 centimeters. So we're going to go ahead and we're going to get this max distance to cover. And then we're going to go ahead and set the distance to cover. And we're going to set it to the max distance to cover. Next, I want to get the location of our actor. So I'm going to drag off our controlled pawn here. And we're going to get actor location. And I want to go ahead and promote this to a variable as well. And I'm just going to call this self location. And we'll plug this in after our distance to cover. Now, in order to find cover, we can do this a couple different ways. You can just grab all the object types that are of the class of our base cover object. But if you have a really large map, it's going to grab every single cover object that exists on the map. And we want to kind of avoid doing that. So what I'm going to use is we're going to drag off from our self location here. And I'm going to search for a SphereOverlap Actors. And what this is going to do is it's going to generate a virtual sphere from a position. We're going to plug our self location into that sphere position. So it's going to be centered on our controlled pawn. And then for the sphere radius here, we can just plug our distance to cover in. Right now that's currently set to the maximum distance. And then for the object types here, I'm going to right click and we're going to search for make array. And we're going to plug this into our object types. And we want to set the object type to world static. And then for the actor class filter, we're going to search for our base cover object. And we're going to go ahead and compile real fast because I want to make sure one thing. With this object types here, world static, we're going to have to go back and look at our base cover object to make sure that it is in fact a world static object. So I'm going to go into our maps folder, open up common objects, and open up our base cover object blueprint. And to make sure that this is a world static object, we want to select the default scene root, and you want to make sure that under transform, the mobility is set to static. And then under cover object, just to be sure, we want to set the mobility to static as well. And this will actually end up helping out with pre-generated lighting. If the object is set to movable, it's going to calculate the lighting as the game runs, as opposed to calculating it when we actually build the level. And then we're going to scroll down and we want to go to the collision. You want to make sure that the collision preset is set to custom and that the object type is set to world static. And the collision responses here can block absolutely everything. And once that object type is set to world static, it is going to respond to our SphereOverlap Actors. So we can go ahead and compile and save this and close our base cover object. And back in our Find Cover BTT, what's going to happen is the SphereOverlap Actors is going to find all of the actors that are base cover objects that are also world static within that range of our player character. And it's going to return an array of all the actors that meet that criteria. So from the out actors, we're going to search for a for each loop. And what this for each loop is going to do is it's going to execute everything in the loop body for each individual item that appears in this out actors array. So if this lists 10 items in here, it's going to perform this for each loop 10 times, one for each actor listed in that array. So for our for each loop, we're going to grab the array element, which is the actor. We're going to drag out and we're going to cast to our base cover object. And then as our base cover object, we're going to drag out, and I want to get the references to those arrows that we're using for the cover direction. And I named mine arrow 1 and arrow 2. So I'm going to go ahead and I'm going to get arrow 1, and I'm going to go ahead and get arrow 2. And if we open up the base cover object real fast, I set it up so that we had arrow 1 and arrow 2, which are what we are grabbing the direction of the cover rotation from. So in our Find Cover BTT, we're going to get references to each one of these, and I'm going to promote each to a variable and call them arrow 1 and arrow 2 respectively. And we'll connect this from our cast. And then from our set arrow over here, we're going to go ahead and perform a sequence. So from our set arrow 2, I'm going to drag out and we're going to search for a sequence. And I'm going to go ahead and I'm going to place a branch in here and connect this up to our then 0 pin. And then I'm going to grab a reference to our arrow. In this case, the first arrow, so arrow 1. Now, we want to get some information on this arrow. So I'm going to create a new function. And I'm going to call this check rotation and distance. And I want this function to do a couple different things for me. So first, we're going to go ahead and under graph here, I'm going to set this to a pure function. And then for inputs, I'm going to click on new. And I'm going to call this one arrow reference. And we're going to search for a arrow component reference. And I'm going to create a new output. And I'm just going to call this return value. And I'm going to make it a Boolean. And I'm going to drag this off to the side here so we have some room. And we're going to have to perform some operations on this arrow to find out if this is where we want to go take cover at. So in order to simplify the understanding of how this function is working, I'm going to use a couple of things repetitively that I wouldn't normally, but in order to break it down so that everybody should have a decent chance of understanding what's going on here, the first thing I'm going to do is I'm going to go ahead and promote this to a local variable. So our arrow reference is going to be a local variable, and I'm going to call this local arrow. I'm going to plug that into our input execution, and we're going to need to do 3 things to this arrow to find out if this is the arrow we're looking for. First, we want to check the arrow's facing direction, and we want to see if it's facing towards the player character so that we can shoot towards the player character. So in order to do that, I'm going to go ahead and I'm going to grab a reference to our local arrow, and we want to get world rotation. Now we're going to want to find out where the player character is and how we're looking at the player character. So we want to go ahead and add a new variable, and we're going to call this player character. And for type, we want the reference on the blackboard, so we're going to search for the blackboard key selector, and we're going to go ahead and make it public. And I'm going to go ahead and drag out and get a reference to our player character here. And we're going to use this a couple different times. So we actually only really need to know his location for anything. So we're going to go ahead and get as actor. And then as actor, we want to get actor location. And then from the return value here, I'm going to go ahead and promote to a local variable. And we're going to call this player care location. And we'll connect this up to the end of setting our local arrow. So we can call upon this to get the location of our player character throughout the function. So I'm going to grab this player care location, and we want to compare the location of this player character to where the arrow is. So off of our local arrow here, I'm going to drag out, and we're going to get world location. And from our get world location, we're going to drag out, and we're going to find the look at rotation. So the world location of the arrow is going to go into the start, and our player character location is going to go into the target. Next, we want to drag off of our get world rotation of our arrow, and we want to get the forward vector. And then we want to do the same thing for our find look at rotation here. Next, we're going to perform a dot operation on these. So we're going to search for a period, and we'll select dot product, and we'll connect our get forward vector from each into this dot product. From here, we're going to drag out, and we're going to search for the A cos in degrees. And then we want to check this angle. This is going to give us the angle in degrees that's difference between where the local arrow is pointing and the direction from the arrow to the player location. So from our A cos D here, we're going to check less than, and we want to see if this is less than a certain value, if it's in this front forward arc. So I'm going to set this to 75, and this value is actually for the half angle, so this is going to look in its front 150 degree arc. We have a condition here that's going to tell us if this local arrow is facing in the general direction towards our player character. So next, I'm going to go ahead and I'm going to duplicate this reference to our local arrow here. And we want to go ahead once again and get world location. And we want to compare this to our self location. So I'll grab that reference to the self location, so where our enemy character is at, And from our get world location, I'm going to drag out and find a subtraction. So we'll subtract a vector minus a vector. And we'll plug our self location into the second pin. And this will get the difference between where the arrow is located and where our enemy is located. And we want to check to see if the arrow is within a certain distance of our enemy character. So we're going to drag off the subtraction, and we're going to search for a vector length. And we're going to want to check to see if it's less than a certain value. In this case, I'm going to check our distance to cover. Now we're going to go ahead and set this distance to cover at some point. But right now the important part is we're checking to see if this is the closest object we found so far to our enemy character. Lastly, I'm going to go ahead and I'm going to duplicate this local arrow. And once again, we're going to get world location. So I'm going to duplicate that as well. And we want to perform a subtraction. So we'll select a vector minus a vector. And we want to use the player character location. So I'm going to get a reference to the player character location. And now we want to see how close this is to the player character. And we want to make sure that this arrow or the cover object is a certain distance away from our player. So we're going to go ahead once again and we're going to get a vector length. And we're going to perform a greater than, because we want to check to see if this is at least a certain distance from our player character. And I'm going to say it has to be at least 5 meters away from our player character. So I'm going to set this value to 500. And then I'm just going to put these a little closer together. I'm going to drag off of the top, condition check, and we're going to search for an and we're going to add another pin. So we have 3 pins in total, and I'll connect these 3 condition checks into our and we're going to go ahead and put a branch in place. So I'm going to drag from our set player character location all the way over to our branch. And then we'll connect our and here into that branch. And from the true, we'll go ahead and we'll set the distance to cover. And we're going to set the distance to cover to the vector length from the second section here. This is the one where we check to see the distance between where the cover is at and where the location of the enemy character is at. So from this vector length, I'm going to go ahead and I'm going to drag out and plug that into set distance to cover. And then we're going to go ahead and connect this into the return node. And we're going to set the return value to true. Then I'm going to duplicate this return node. And we're going to drag from our false into the second return node. And we want to make sure the return value is false. And then I'm going to go ahead and I want to drag some comment boxes around these guys. So I'm going to break them up a little bit further. And so for this top one here, I'm going to go ahead and put a comment box around this. And we're going to call this is player in forward arc of arrow. Then we're going to grab the second group here, and this is where we check the distance from our enemy to the cover. So we'll put a comment box around that, and we'll call this check distance from enemy. Well, actually, this is going to be from the enemy character. So, yeah, we'll call it enemy character to arrow. And for this third grouping here, we're checking to see if it's at least a certain distance from the player character. So I'll throw a comment box around that, and we'll call it check to see if arrow is at least 5 meters away. To summarize what this function is doing is we're basically getting a reference to the arrow that we're feeding into the function, and then we're setting a variable that stores the player character location. And then in the first part of the function here, we're checking to see if the player is in a certain forward arc from the arrow. In this case, the half angle is going to be 75 degrees, totaling 150 degrees looking forward. We're then going to check the distance from the enemy character to the arrow, and we're going to see if this is the closest arrow that we found so far. And lastly, we're going to check to see if the arrow is at least 5 meters away from our player character. If all three of these conditions are true, we're going to go ahead and set the distance to cover, because we've now found our new closest arrow to our enemy. And then we return a true. But if any one of these is false, we're going to go ahead and return a false, and we can proceed from there. So I'm going to go ahead and compile this, and I'm going to close this function and go back to the event graph. So I'm going to go ahead, I'm going to drag this branch off just a little bit more, and from our arrow 1 reference here, I'm going to search for that check rotation and distance function that we just created. And we'll go ahead and throw up a branch and plug the return value into our branch, and we'll plug our then 0 into this branch. And then we're going to need to store where we want to move to, where this arrow is located at. So I'm going to go back to the enemy AI behavior tree real fast, and we'll go to our blackboard. I'm going to add a new key, and it's going to be a vector. And we're going to call this move to location. And we're going to go ahead and save, and we'll go back to our find cover BTT. So if this ends up matching all of the criteria so far, we're going to drag off of our arrow here, and we're going to get world location, and we want to set it to that blackboard value. So we'll add a new variable in. We'll call it move to location. And we want it as a blackboard variable, and we'll make it public. And then go ahead and get a reference to our move to location. And we want to set as a vector. And we'll plug our true into this set blackboard value as a vector. And we'll connect our get world location into the value. Next, we're going to want to set our isCoverAvailable blackboard value. So I'm going to go ahead and get our isCoverAvailable blackboard value. And we're going to go ahead and set as a Boolean. And we're going to set this value to true. And we don't need the second branch here. I'm going to get rid of that. And I'm just going to tighten this up a little bit. And I'm going to go ahead and duplicate this entire grouping. And then we want to grab our arrow 2 reference and replace the arrow 1 reference. And we'll drag our then 1 connector to this branch. And then I'm going to go ahead and backtrack to our for each loop. And on completed, I'm going to drag out. And I'm going to search for a finish execute. And we'll set it to success true. So that is going to complete our find cover BTT. So what is this function doing? As a review, From the beginning, we're going to go ahead and immediately set the isCoverAvailable Blackboard value to false. And we're going to set our distance to cover to the max distance to cover. We're going to get the location of where our enemy character is at. And then we're going to create this SphereOverlap Actors, which will generate a sphere from the location of our enemy character. And it's going to be the size of the max distance we're going to look for cover, which in this case is 30 meters. It's going to search for object types of world static, and it's going to filter out all of the base cover objects. And it's going to add those into an array. And then on the array, we're going to perform a for each loop. So for every object that's listed in this array, we're going to go ahead and cast to our base cover object. We're going to get the references to the arrows. And then we're going to test each one of those arrows to see if it meets certain criteria. So we're going to check to see if it's rotated in a favorable direction towards the player character. We're going to see if it's a certain distance away from our player character. And we're also going to check to see if it's the closest one we found so far to our enemy character. If it matches all those conditions, it's going to go ahead and set the move to location on our blackboard. And then it's going to tell the blackboard that cover is available. So we'll set that value to true. And then it'll perform the same actions on the second arrow as well. And so it'll go through every single one of the cover objects listed in this array. And once it completes, it's going to return a finish execute, which will list the task as being successful. So hopefully you got that all and it makes sense, at least a little bit. So I'm going to go ahead and compile and save this, and we can close out of our find cover BTT and go back to our behavior tree. So the next thing we're going to do in our sequence is we're going to call that find cover BTT. And we're going to set the isCoverAvailable to our isCoverAvailable Blackboard value, the player character to our player character Blackboard value, and the move to location as our move to location Blackboard value. And we're going to call this task simply find cover. And now we're going to have to detail what happens when our player finds cover and when he doesn't find cover. So there might be some circumstances where he ends up trying to search for cover and no cover objects end up fulfilling the guidelines that we set forth. So we're going to go ahead and we're going to drag out and grab a selector. And from our selector, we're going to drag out and search for a sequence. And then we're going to add a second sequence. And then for the first sequence here, I'm going to right click. We're going to add a decorator Blackboard. And the Blackboard key is going to be the isCoverAvailable. And we want it set to isSet. And then we're going to set the observer aborts to self. And then for the node name, we can call this cover available. And then for the second sequence, we're going to go ahead and add a decorator Blackboard. Once again, the Blackboard key is going to be isCoverAvailable. And we're going to set the key query to isNotSet. And we're going to set observer aborts to self. And then finally, we can name this cover not available. And so from our cover available sequence, we're going to go ahead and we're going to call a move to. And we're going to set the Blackboard key to be the move to location that we set. And we can leave the acceptable radius at 5. Next, we're going to go ahead and call the set taking cover BTT. And we want to set it to true. So under default, we'll set is taking cover to true. The is taking cover will be our is taking cover Blackboard value. And then for the node name, we can just call out what it's doing, which is set taking cover. And then finally, we're going to perform a wait operation. And I'm going to set this to a wait time of 4 with a random deviation of 2. So what this is going to do is every time it runs this wait, it's going to wait 4 seconds, and it's going to randomize that 4 seconds to be plus or minus 2 seconds. So it's going to basically wait between 2 seconds and 6 seconds. And I'll grab this and I'll just slide this over a little bit. And if cover's not available, I'm going to have him just outright rush at the player just like our assault character does. So from our sequence, I'm going to drag out and we're going to search for the move to. And we're going to set the blackboard key to the player character. And we'll set the acceptable radius to 300 or 3 meters. So we'll go ahead and save. And so far, we have it set up so that when he enters the cover sequence, he's going to unset not taking cover. He's going to stop firing his weapon. He's going to look for cover. And then, depending on if cover is available, he will move to the location of the cover, set as taking cover, and then proceed to wait. If cover is not available, he's just going to go ahead and move at our player character. So let's go ahead and test this out. We're going to go back to our test map. I'm going to hit Save All. We'll select our enemy character here. And to make it easy, I'm just going to set him into guard mode. And then for combat type, we'll select cover. So we'll go ahead and hit Save. And we'll hit Play. And let's go ahead and get his attention by shooting at him. So he runs over there. He hides behind cover. And he is doing a little flippy thing where he's popping in and out of cover. So after he gets through his wait cycle, I'm going to go ahead and we'll take a look at the enemy behavior tree right now and the way that this is functioning. So as we watch him, he is going to set not taking cover. He's going to stop firing his weapon. He's going to fire the find cover object. He's going to fire the find cover task. And he has cover available, so he's going to move to that location that qualifies for the conditions we set. He sets as taking cover, and then he ends up waiting. Alright, so we have the movement settled for our character. Now we have to handle him attacking our player character. And I know it looks a little broken because he keeps getting up and out of cover, but this will be corrected after we take care of what we're going to do next. So, from our initial cover sequence here, I'm going to drag out, and we're going to add in a new sequence. And we're going to add a decorator, and we're going to call on our check firing arc BTD that we created earlier. If we remember what that does, that checks to see if the player character is within a front firing arc of our enemy. So for the default player character, we're going to set that to our player character blackboard value. And we'll go ahead and set the observer aborts to self. And I actually messed up here. This isn't supposed to be a sequence. This should be a selector. So I'm going to drag out. I'm going to add a selector. And we're going to move our check firing arc over onto the selector. And the sequence here, I'm going to connect to our selector. And I'm going to drag out from our selector as well. And we will search for another sequence. And then for this check firing arc here, I'm just going to rename it as well. So for the node name, I'm going to search for is in front firing arc. And then we're going to have to dictate how we attack our player, whether or not we are taking cover or not. So for the first sequence here, I'm going to right click. We're going to add a decorator blackboard. And the blackboard key is going to be as taking cover. And we want it as set. And we'll set the observer aborts to self. And for the node name, we'll just call this taking cover. And then for the second sequence, we'll do the same thing. We'll add a decorator blackboard. We'll set the blackboard key to as taking cover. We'll set observer aborts to self. And we'll call the node name not taking cover. And then for our sequence here, I'm going to go ahead and drag out. And we're going to search for our start stop firing weapon. And in the details panel, we'll set start firing weapon to true. And we'll call this start firing weapon. And then we're going to perform a wait. And we'll just leave it at 5 seconds for now. And then for our sequence of not taking cover, I'm going to call a move to. And we'll set the acceptable radius to 300. And we'll set the blackboard key to the player character. Next, we're going to drag down from our sequence, and we're going to start stop firing weapon. Once again, we want to set start firing weapon to true. And we'll call this start firing weapon. And then once again, we'll go ahead and drag off the end here, and we'll perform a wait. And 5 seconds will be fine for that too, as well, for the moment. So we'll go ahead and save. And let's go ahead and hit play to test it out. And I'm going to bring up our enemy behavior tree so we can watch this and see what happens. Let's see, I'll make some room right here. We'll open up our window, and we'll go ahead and shoot at him to get his attention. And he moves into the cover sequence. He goes and he finds cover. He waits. And once he's done waiting, he goes, stands up, and he shoots at us. And then he ends up recycling through the whole thing again. And we could also test it out to see what happens if we end up running around him. Or even better, I'm going to go ahead and I'm going to run up next to the cover right here. And he's still in his front firing arc, so he's going to complete shooting at us. Well, once he completes that, he stops taking cover. He finds a new cover location because we're too close to the one he was already occupying. It's no longer the closest to him that fills the requirements that we set. So he goes and finds another cover. So if I come over to him right here, after he completes his next shooting cycle, he's going to attempt to find cover again. So he backs off to that. And let's try running past him and see what he does. So I'm just going to walk outside of his front angle. And he kind of rolls over to that other position right there. But he's still shooting his weapon. Alright, so the problem that was occurring while he kept firing afterward was this delay in the fire rifle event. So when we call the fire rifle event, it sets is aiming and is firing to true. And then we hit a delay for 1.5 seconds. So if we move behind the enemy character during that delay, this completed still fires afterward. So I added in a branch that checks to see if firing is still true. Now when we call stop firing, it'll set this is firing false. So as this execution chain comes along, it'll go ahead and set is aiming to true, it'll set is firing to true, and then we perform a delay. So if stop firing is called during this delay, when the delay completes, we're going to check is firing again to see if it's been reset by the stop firing function. And that'll correct the issue of the enemy continuing to fire after we walk past him. So if we compile, save, and we'll hit play, we'll go ahead and shoot at him. He goes ahead and takes cover. And we'll wait until he pops up, and then we'll run past him, and he will then stop firing. So at this point, he is cycling cover. He's shooting at our character, and he has a bit of inaccuracy in his weapon due to the rifle spread that we have. But he is successfully shooting at our character, and he's successfully taking cover behind different objects. So initially when the behavior tree is first started and he first switches to cover mode, it'll set these first two here, the set not taking cover and the stop firing weapon, which will essentially do nothing to us. At least it's not going to be something that's noticeable because all of these are already set this way anyway. The next, he's going to find the nearest cover. So once he finds a suitable location for cover, it'll come down to the selector and it will run the cover available. So we're going to move to the cover location. He's going to set taking cover as to true, and then we're going to wait for a random amount of time between 2 and 4 seconds. And you can vary this time up to even be a little bit greater than this. So we could set it to be something like 6 plus or minus 3. So that'll give us between 3 and 9 second wait time. And that'll make the enemy characters, once we have more than one on a map, look a little more varied. So once this sequence ends up completing, this selector completes, and it moves to the next node in the sequence, which is going to check if we're in the front firing arc. And at this point, we're taking cover, so he's going to start firing weapon, which sets us to aiming, which will power the animation blueprint to cause him to stand up and then start firing the weapon. And then he's going to wait this 5 seconds. And once this sequence completes, this selector is completed. And this is the last in the original sequence node here. So this node will complete. And then this selector will complete. And finally, this selector will complete. So essentially, every time one of these nodes completes, it resets the whole tree. So it'll start down from the root. It'll start the change combat status. It'll see that we're in the combat mode. From the combat mode, it'll see that we are in the cover combat type. It'll set not taking cover. It'll stop firing the weapon. So if we're coming from this node before, where we started firing the weapon and then we wait, it'll go ahead and stop firing the weapon for us. And by calling this set not taking cover first, by the way we set up the animation tree, it's not going to affect him because he's already standing up at this point. So this is not really going to do much other than just reset not taking cover. He's going to stop firing his weapon, and he's going to go ahead and look for cover. If he's already at the closest location to cover, it's going to move him to the location he's at. He's already where that cover is located. So it's going to set taking cover, so he'll go ahead and duck back down, and then he'll wait this random amount of time. And then he'll go ahead, he'll start firing our weapon, and then he'll wait for this 5 seconds, and the tree will restart again. And this also works well for when he is not in cover as well, because if we complete the find cover task here, and we're not able to find cover or any suitable cover for us, he's just going to move towards the player character. So it's then going to travel down the second selector here, where he's going to attempt to move to the player again. And the reason I put this in here is in case the player character is moving around. So he's going to move at us. He's going to start firing his weapon, and then he's going to wait 5 seconds, at which point the entire tree will report successful again. It'll drop back down here, set not taking cover, and stop firing the weapon again. So if you have any questions or comments, go ahead and leave them down below. And as always, thanks for watching.